Okay, so now that we've gone over demand and supply separately, let's put them together. Remember, in our system, the demand curve was given by the equation Q is equal to 12 minus P, and the supply curve was given by the equation Q is equal to 2P. Okay, and we can draw these on a coordinate plane, right? So we can say price and quantity. We have our downward sloping demand curve, and we have our upward sloping supply curve. And what we're interested in knowing is what is that equilibrium price or that intersection point? In other words, we want to figure out how much pizza is going to be bought and sold and what the price of that pizza is going to be. So how can we do this? The easy way is to take these two equations and notice that we have two equations with two unknown variables, which means we can set them equal to each other. So we can say, for example, that 12 minus p, which is the amount of pizza bought at any given price, must be equal to the amount of pizza produced at a given price, which is given by 2p. Through some math magic, we can move this minus p over here by adding p to both sides. That will get us 12 is equal to 3p. And if we just divide both sides by 3, we get 4 is equal to p. So now we've solved for this number here, and we know it's 4. How can we figure out what the quantity is? Okay. Well, what we can do is we can take this 4 and plug it into either here or here. And then we can figure out what the quantity is going to be. So let's just do both just so we can check. So if I take 4 and plug it in here, I get 12 minus 4 is equal to 8. And if I plug 4 in right here, and I say 2 times 4 is equal to 8, then we know we've gotten the correct answer. So the equilibrium quantity in this case is going to be 8. Now let's think about this for a minute. At a price of $4 for pizza, you want to buy 8 pizzas. And at a price of $4, the producer of pizza wants to make exactly 8 pizzas. In other words, the pizza makers are making exactly as many pizzas as you, the consumer of pizza, want to purchase. So there's no wasted pizza, which, let's be real, would be a tragedy. And at that price, nobody is sad that they don't get more pizza. Sure, they might be sad that they aren't buying another pizza, or that they don't want another pizza, or that they've run out of pizza. But the reason that people aren't going to buy another pizza is not because they're not hungry enough, but because it's not worth it to them at that price. Now, here's the thing. It's cute and fun to talk about the market for pizza, how much pizza you're willing to buy at various prices, how much pizza someone is willing to sell at various prices, etc., etc. And frankly, if you understand this example, you can apply it to basically anything, from cars to houses to groceries, and everything in between. And what's truly remarkable is how well this model works for how simple it actually is. Now let's dive into actually shifting the curves around and seeing what happens. Okay, so I'm just going to clear the board real quick. And what we're going to do is we're just going to look and see intuitively and graphically what happens when there is a change in the market for pizza. Okay, so we have our quantity and we have our price. We have a demand curve. We have a supply curve. I'll just denote these with subscripts 1. Okay, and we'll say that the equilibrium was the same, 4 and 8. Okay, so what happens if, for example, college students decide that they want to buy more pizza, perhaps over a homecoming weekend or a big party? Well, if we're having a situation where the consumers of pizza are changing their behavior, then what we do is we shift the demand curve. So in this case, the demand curve would shift to the right, okay? And I should note this, that whenever anything increases, the curve shifts to the right, and that is always going to be true, okay? And what happens to the equilibrium price? Well, the equilibrium price will go up to some other number. And importantly, the equilibrium quantity will increase as well. Okay? We can also think about what has happened in the real world, okay, by looking at changes in the producers of pizza. Okay, so it's no secret that pizza is delicious. As you can probably tell, I eat a little bit too much of it, but that's okay. And we'll just say Q1. All right, we'll just denote some random starting point. If there were a change in the ability of pizza making companies to produce pizza, so for example, the advent of the pizza dough press, which basically takes a ball of dough and you press it into the shape of a pizza, it means that we no longer have to have someone hand stretch or hand roll the pizza. If any of you have ever made pizza at home, rolling out the dough is one of the harder parts. But pizza companies typically have a machine to do that. And so, with the advent of this machine, it is now easier for pizza companies to produce pizza. We would represent this by an increase in the supply. Okay, so if the supply curve increases, we just shift that curve to the right, and this will result in a lower equilibrium price and a higher equilibrium quantity. Okay? And we can think about other instances where the demand curve shifts to the left, which would be a decrease in demand, or the supply curve shifts to the left as well. And I'll leave that to you to work out on your own.